Okay, continuing on with 3.3, the rational zeros theorem. What this is going to tell us is that we have some polynomial, and I'm going to use the one on page 333 for the example. 6x to the fourth plus 7x to the third minus 12x squared minus 3x plus 2. And what we're trying to do is find some rational number, which rational is a fraction, some rational number, p over q, that is a zero of this polynomial. And what the book will tell you is on how to decide what potential rational numbers could work for this. You just need to follow these two simple rules. Your p has to be a divisor of this last constant. So the only constant in your polynomial which does not have a variable with it, you have to decide, you have to take your p and make it a divisor of that constant. So two numbers, or the numbers that divide 2, are plus or minus 1, plus or minus 2. And now your q, your denominator, the numbers that it can potentially be are the divisors of your leading coefficient, or your coefficient that is multiplied by the variable with the highest degree, which in this case is 4. So now, the numbers that can divide 6, okay. So now we have our combination, or our possibilities, of what our fraction could look like. So it could be, your p could be 1 or 2, or -1 or -2. And then your q, your denominator, could be 1, 2, 3, or 6, positive or negative, and any one of those combinations. Now the way you check it is you just say p is 1, q is 1, so we're going to check 1, because 1 divided by 1 is 1. And you just do what we've done before. So you take the coefficients in front of the variables, okay, and now you just work it out like we've done before. So the 6 will drop down, you multiply it by 1, comes here, you combine them, you get 13. Multiply 13 by 1, comes here, combine those, you get 1. Multiply it by 1. Combine these, you get -2. Multiply that by 1, you get -2 here. Combine them, and you get a 0. So because you get a 0, 1 over 1 works out, and 1 over 1, or -1 over -1 works out. So you know these two here are safe. Now what you can do is you can check 1 over 2, -1 over 2, you know, this combination here will just simply be the same thing here. So all you have to do is write out all your different combinations and check them. But as you can see here, it takes 5 seconds to check any one number. So all you have to do now is the legwork in checking them. And that should be everything that you should do for this homework in 3.3. So let's move on to 3.4.